Good day, grade 8. I am your teacher, Marie.
Good day, grade 8. Now, we're going to discuss a new topic. Let us enjoy watching while learning. The triangle inequality theorem. So the triangle inequality theorem are the length of the two triangles inequality. The sum of the length of the two sides of a triangle is greater than the third side. So we can say that the two triangle is of a triangle inequality theorem if the third side is always greater than the third side. Okay? So we have the triangle, the side of a triangle A, B, C, side A, side B, and side C. So side A plus side B is greater than side C. Side A plus side C is greater than side B. Side B plus side C is greater than side A. So this will be the length of the two-side inequality. That will be the three formula that we have inequality is if our given triangle, the side of the triangles, satisfies the condition, we have proved the triangle inequality theorem, or the length of the two-side inequalities is greater than the third side. So let us have an examples. Which of the following could be represented the length of the side of the triangle? So here, we can prove by the use of the three conditions that we have. The theorem says that the length of any two sides should be less than the third side. So in letter A, we have 12, 12, 12. So 12 plus 12 is 24, and 24 is greater than the third sides that we have. So in fact, it is triangle. So in fact, this can be the equilateral triangles. So letter B, we have 12, 13, 14. So 12 plus 13 is 25. 25 is greater than 14. And 12 plus 14 is 26 is greater than 13. And if we have 13 plus 14 is equal to 27, 27 is greater than 12. Therefore, the length of the two sides is greater than the third side. It can be a triangle. So letter C, we have 12, 14, and 26. So even though we have 12 plus 26 is 38, which is greater than 14, if we have 14 plus 26 is 40 is also greater than 12, still 12, 14, 26 cannot be formed a triangle because 12 plus 14 is 26 and 26 is not greater than 26. It is equal. Cannot form a triangle. Letter D, we have 12, 13, and 27 or 12, 27, 13. So 12 plus 13 is 24. It is less than 27. Hence, 12, 27, 13 cannot form a triangle. So, if we have the three sides of the given triangles, then it satisfies the three conditions that we have, then it forms a triangle. We have the Henge theorems. This inequality theorem involves two triangles. We can have learned that the two triangles are congruent if their part can be paired so that their corresponding side and their corresponding angles are congruent. Henge theorems are the SAS inequality. So this will be the SAS inequality. If the two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Let us have an example to make it more visualize how we have the SAS inequality. So number one example is if we have the triangle SKY and the triangle LAB. So here, if side SK is congruent to side LA, side SY is congruent to side LB, and the measure of angle S is greater than angle B, then KY is greater than AB. We have the SAS congruent. So here, you have proof that the two angles between the two sides that we have is not congruent. Okay? Number 2 example, we have the triangle FUN and the triangle CRY. So here, if the side FN is congruent to CY or the side CY, UN is congruent to LR, and the measure of angle N is less than the measure of LY, then FU is less than CR. So the measure of the side of FU and CR are not equal. Okay? Then we have the converse of hinge theorem or the SSS inequality. So if the two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangles. So here, number 1 example, we have the triangle SKY and the triangle LAB. So if the side SK is congruent to the side LA and the side SY is congruent to LB and KY is less than AB. So the side KY is greater than the side AB. Then the measure of angle S is greater than the measure of angle L. So this will be the converse of the first theorem that we have, the SAS theorem or the SAS inequality. So this will be the converse. Second example, if a triangle FUN and a triangle CRY. So here we have if we have the side FN is congruent to side CY, UN is congruent to LR, and FU is less than CR, then the measure of the angle N is less than the measure of angle Y. Now, let us have the definition of inequality. For any real number A and B, A is greater than B if and only if there is a positive number C such that A is equal to B plus C. For instance, we have 8 is equal to 6 plus 2, then 8 is greater than 2 and 8 is greater than 6. We already discussed the difference. So let us prove the triangle inequality theorem stating the sum of the length of the two sides of the triangle is greater than the third side. So given the triangle MNO, so let us prove that the segment NO plus the segment MP is greater than the side of MN. So here is the statement and the reason. So let P a point on MO so that O is between point M and point P. And segment NO is congruent to OP. We have constructing a congruent segment. Now, we have the side MO plus side OP is equal to the side MP. Definition of between is, or the two, if we have the segment congruent segment, the two segment is congruent. Next, we have the MO or the side MO plus the side PO is equal to MP by substitution. So we have here that the angle PNM is greater than the angle of PNO. O is the interior of angle PNM. The angle P is congruent to angle PNO. Definition of isosceles triangles. Angle P is less than angle PNM by substitution. We have substituted that angle P is equal to angle P and O, and angle P and O is less than angle P and M. Therefore, angle P is less than angle P and M. Then the side MP is greater than side MN by inequality angle theorem or angle side theorem. So, side MP is greater than the side MN. Inequality angle theorem, or the side is greater than the angle theorem. So, segment NO plus segment MO is greater than segment MN by substitution in the statement 3 and statement 7. The measure of an interior angle of a triangle is greater than the measure of the remote interior angles. Given the triangle MNO with the ray CD extended. So here is the constructed picture of the given triangle MNO with the extended CD. So we have to prove that the measure of angle BCD is greater than the measure of angle ABC, and the measure of angle BCD is greater than the measure of BAC. Now let us prove. So here is the proof by constructing the PM is equal to MC and AM is equal to ME. We have the measure of angle PMA is equal to the measure of angle CME. By vertical angle theorem, we can say that the triangle ABM is congruent to triangle ACM, and it is used by the SAS inequality. And that will be, we have the measure of the angle ABM is congruent to the measure of angle ABC, and the measure of angle BCD is greater than the measure of BAC. Another way of proving by the use of indirect proof, using this will prove that inequality angle theorems, and let us have try. So given a triangle GHI with the measure of angle H is greater than the measure of angle I. So let us prove that IG is greater than GH. Now let us prove by the use of indirect proof, or assuming that IG is not greater than GH. Case number 1. So here is the case number 1. So IG is equal to GH. So case 1, we have GI is equal to GH. Then let us prove. So GI is equal to GH given angle 1 is congruent to angle H by the isosceles triangle theorem. Then we have the measure of angle 1 is equal to the measure of angle H. Definition of congruent angles. Another is case number 2. GI is less than GH. So statement and reason. So GI is less than GH given angle H is less than angle I. An equal side theorem.
Thank you. Enjoy watching while learning. This is your teacher, Miss Marimar F. Figalan.